As the word blockchain seems to be increasingly in circulation, the talk of how this technology is set to disrupt our procurement roles to offer increased supply chain visibility also leaves us considering risk exposure. Blockchain technology can be surrounded in mystery, wrapped up in lots of tech talk, and is often linked to financial transactions and Bitcoin or cryptocurrency. So as procurement professionals, we can be left trying to understand how blockchain is going to fit into our current systems and processes. How will blockchain technology shape our organisation's activity and output? And what plausible solutions will it deliver to enhance our procurement roles? SIPS would like to introduce Matt Birks, who is Head of Delivery at ByzGen. Matt aims to take some of the hype out of the tech talk and put some practical guidance forward in this webinar to highlight what blockchain is and isn't. If I can pass over to yourself, Matt, so you can proceed with the webinar presentation. Thank you.
Thanks, Gina. Thanks for bringing me along today. So I'm going to start really by discussing at a very high level what blockchain is, and then equally as importantly, I'm going to just discuss what it isn't. We'll then spend a little bit of time talking about how blockchain systems actually work and why they're so secure, and then finish off really by just touching on blockchain's usefulness at an enterprise level. So what is blockchain technology? I thought it'd be worth trying to define kind of what it is. There's lots of different definitions out there, but I quite sort of like this one that we've got sat on the slide in front of us. It is complex, that's the first thing to realise. But in a nutshell, blockchain is really composed of the following things. First and foremost, it's a distributed network of computers, and we call them nodes. So it's not a computer in itself, but somewhere within that computer you will spin up a node, and you need a group of nodes to make a blockchain work. And as I said, that node or those nodes can be within a single computer. It could be on a particular device, on a cloud-based server. It really doesn't matter, as long as the hardware can take the code required to spin up the node. You can start to set a blockchain up. Each node then contains a chain of blocks, and within each block there is a ledger, what we call a ledger, which holds a list of transactions. And each of those transactions is linked to the previous transaction for the resource it represents. So that resource could be a piece of cryptocurrency, or it could be a piece of intellectual property, or anything really. And most importantly, the output of every transaction that goes on within a blockchain is incorruptible, secure, and fully auditable. So if those are the kind of key characteristics, then I'm going to now talk about what blockchain technology isn't. So, and one of the most important concepts here is that I'm talking about blockchain as a standalone technology. So as a standalone technology, it is not a data analytics tool. We get asked quite a lot of stuff from our customers regarding the technology, obviously. And this is one of the things we get asked the most. What kind of analytics can you run with blockchain? It is not an analytics tool. But that is not to say it is not an ideal partner for data analytics, but it is essentially a dumb beast, which is dependent on its deployed architecture and its deployed protocols to have useful effect. So it's not an analytics tool. A lot of people think blockchain is simply Bitcoin or cryptocurrency, to use a broader term. It isn't. Cryptocurrencies are a really good example of an application that uses the concept of blockchain to solve a specific problem, which in this case is secure peer-to-peer exchange of value. But to say that blockchain is cryptocurrency, the terminology is just not as interchangeable as that. It's a lot more than that. So artificial intelligence, again, a lot of our customers, they think or they often believe there's an artificial intelligence aspect to blockchain. Again, as a standalone technology, blockchain isn't particularly intelligent. It's a group of protocols, that work within a specific architecture to give you a number of capabilities. And again, just like with data analytics, those capabilities that you can get from using blockchain or from employing blockchain can support artificial intelligence. applications, but as a standalone product, as a standalone thing, blockchain isn't a form of artificial intelligence, nor does it have any aspect of artificial intelligence involved in it. And finally, again, a lot of our customers feel that using blockchain will answer the bulk of their technology problems, and it really doesn't. It's got a lot of capabilities, specifically surrounding kind of security and audit, that are very useful to the enterprise. But we're very honest with our customers. A lot of the time, well, not a lot of the time, some of the time, we find that their problem, whilst blockchain could solve it, it's actually much easier to solve with a more traditional solution. It's cheaper, it's quicker. It's not to say blockchain is overly expensive. It's just that there are traditional solutions out there that are very competitive and can solve certain problems perfectly well. So it's not the answer to every enterprise technology problem. Okay, so again, at a very high level, I'm going to just try and describe how blockchain actually works. And this is a very high level. It's extremely complicated stuff. So I put together a quick animation to try and describe how the tech works. Please bear in mind while I do this that there's a lot of cryptographic activity supporting blockchains. For example, with generation and encryption of keys and key material. And as I said, it is extremely complex, and we can go into more detail in the next webinar. But I think for now, I just wanted to highlight that the cryptography aspect is there, and that it's a really important part of why the technology is so innovative and so secure. So, as I said before, the technology requires a group of nodes to work, and the diagram on the right is just trying to sort of depict a group of nodes, those black dots. Each node is enabled to sort of to talk to the entire network, and as we said before, each node contains an identical copy of the ledger. And the ledger contains all the transaction data surrounding a specific data object, again, which could be intellectual property, could be currency, could be legal documentation, could be anything. And within each ledger, you've got that chain of blocks. And a new block is formed every time a piece of data undergoes a transaction. So if I've got my piece of IP that I'm using the blockchain to encrypt and secure, and I want to make a change to that intellectual property, maybe there's been a change in a design, a specific design or something like that, and I want to make that change, all the nodes have to agree in consensus before I can do anything. And they've got to agree a few things, but first and foremost, they've got to agree that I'm a user of the system, and then they've got to agree that I actually physically have permissions to go and make the change that I want to make. Because you can be a user of a blockchain system, and you can have numerous different ways of setting up the permissions of the users. So I might be somebody who can view information, but I can't change it. I might be somebody who can change only certain information. So it's very similar to contemporary systems in that respect, except all the nodes have to agree that I am who I say I am before any change can be made. And when they all agree, and under normal, in this diagram, you've got every node agreeing that we're going to make a change. Normally you have a threshold, so it might be which you can set to whatever you want to. So you might be talking about like an 80% threshold for agreement. But whatever you've set that at, when they all agree, the change gets made, it gets recorded on the chain, and a new block is written. And all that information, as we said before, is now totally immutable. It cannot be changed. So if that's in a nutshell how it works, a lot of people want to know how secure it is compared to what they're using today. Put simply, blockchain is extremely secure. And there's a number of reasons for that. Again, as I said before, the cryptographic aspect is a big reason. But again, I'm going to leave that till the next webinar, just due to its complexity. But the other main reason really is that sort of that design that I've just shown you, that architecture I've just shown you, that blockchain is secure by design. A normal relational system, so the kind of system that most enterprises use, we have a centralized server database with running numerous different bits of software for the enterprise. That centralized place is where any transactions that occur within the enterprise, that's where they are approved, logged, etc. And in that scenario, you'll have various people with administrator rights and that sort of thing. You'll have various other ways of getting into the system. And that's a big weakness. That's a point of attack for a hacker, for example. Now with a blockchain, every node has a copy of information. So as opposed to having that one centralized server in a traditional relational system, with a blockchain, every node has a copy of information. So the point I'm trying to make is that assuming a hacker could even get through all the cryptography and the cryptographic challenges that blockchain entails, even if they could get through that, they would have to initiate the same change in every single block in the chain at the same time and within every node, i.e. to get that agreement. And that just isn't practically possible and takes massive computing power in a real world scenario. So if you want your data to be assured, blockchain is an extremely, extremely good way of doing it. And then finally, I just want to touch on the so what. The blockchain gives the enterprise a number of distinct sort of capabilities that contemporary systems really don't possess. As we described in the last slide, it's extremely secure, but it also gives you this immutable data transaction history, which is that single source of truth and assurance of your data. It gives the enterprise the ability to work securely over fragmented networks. We find a lot of our larger customers have a number of different systems, a number of different servers. They've got a kind of patchwork quilt of a sort of IT architecture, and that really hampers their ability to collaborate. But what they don't want to do is have to completely rip that system out they've spent a lot of money on developing over the years. Even though it's not working to its most efficient level, they can't physically afford to stop doing that and start with something new. And one of the useful things about a blockchain is it can form the glue between fragmented networks and disparate systems by linking in with them all and enabling them to talk to each other. So it really does enhance collaboration in a very secure way. Some people might have heard of smart contracting. So blockchains can run these things called smart contracts, which again are essentially program contracts that sit in the system. When 2 or 3 things are achieved, then an output occurs. And it sounds very simple, but if you set up a number of these within the organization, you can really streamline process and take out a lot of third-party activity. Because the blockchain, again, if something happens, the blockchain has immutably recorded why it happened. So you will only ever get the right result from a process. Again, you get that cutting-edge data encryption as well when using blockchain. And again, a lot of our customers, a lot of them we find are struggling to completely migrate to cloud-based services and use the Internet of Things because they're worried about the security of their information. But if you're encrypting and assuring your data using blockchain, again, it can be a very good way of enabling your organization to shift a lot of its activity into cloud-based services, because using blockchain gives you that confidence. And finally, perhaps most importantly, it's fast and it's scalable. Again, I think there is some mythology around blockchain that it's quite slow. That really isn't the case with contemporary systems. Then, as long as they're deployed correctly, they are fast. And by the nature of the architecture, those nodes if you want to grow it, you just spin up more nodes. It's an extremely scalable system as well. But it's real power, and I think the key takeaway from this particular webinar really is that its power is only ever really realized when it's paired with other complementary technologies. So blockchain as a standalone tech works really well in certain scenarios. You know, cryptocurrency is a good example of that. But from an enterprise perspective, and certainly from ByzGen, from what we've seen, its real power is realized when you pair it up with things like artificial intelligence, or like some of your existing systems that just need to be able to collaborate better, for example. That's when you can realize the real power of it. So it shouldn't be viewed as a standalone technology. It's something complementary. It's an unsung hero. It sits in the background, assuring data, delivering you that audit and that transaction history, you know, managing users, and making sure that your systems are all talking to each other in the right way.
Lovely. Thank you, Matt, for the overview of blockchain technology and the security elements. SIPs are looking forward to expanding our guidance material around blockchain, so do check the SIPs knowledge area for further webinars and white papers that discuss plausible applications of blockchain and highlight some of the business sectors that are already leveraging this disruptive technology. Thank you for viewing this SIPs webinar.